Alright, this video is going to focus on derivatives, the power rule, quotient rule, and the product rule. So first thing first, derivative, the power rule, one of the most basic ones, is just saying f of x, if f of x is equal to x to a power, the derivative of it, or f prime of x, is equal to the power times x to the n minus 1 power. So simple example, we do x squared. So f prime of x is, break down the 2, and then 2 minus 1 is 1. Another example, f of x is equal to, 4x to the 5th. Alright, f prime of x is 4 times, again, break down the 5, bring the exponent down, so it's 5 times x to the 5 minus 1, which gives you 4. And then this becomes 20x to the 4th. So I guess a better definition for this would be if f of x is equal to c x to the n, where c is any constant, f prime of x is equal to cn times x to the n minus 1 power. Simple as that. Alright, another example. We say, what if the exponent is a square root, a fraction, just like x to the 1/2, which we know it's x squared. So anytime you're going to see a square root or cube root or whatever, put it back into the fraction, because that's the only way you're going to be able to do a derivative. So f prime of x is equal to, we do the same thing. N doesn't have to be a whole number, it can be any number. So bring down the 1/2, and it's times x, and 1/2 minus 1 is, of course, negative 1/2. So this is going to be 1 over 2 times the square root of x. So we do one more. F prime of x, f of x is equal to x plus 5 to the cube root. Okay, so again, bring the 1/3 down, times, this is say the same, x plus 5, and then 1/3 minus 1 is negative 2/3. So this answer is 1 over 3 times the cube root of x plus 5 squared. Because remember, this means that. That means that. So again, the answer is 1 over 3 times the cube root of x plus 5 squared. Alright, product rule. Product rule says, let f of x and g of x both be differentiable functions. Alright, so if they're both differentiable, then the derivative of f times g is equal to f prime g plus f g prime. Alright, so remember, we have to keep it in this order because it will help us a lot when we do the quotient rule. So one example is, let's say our function is x cubed sine of x. Right, so we label this f, label this g. What I like to do is just take the derivative right away. So f is this, so f prime is 3x squared, g prime is cosine of x. Alright, and so when I would just plug it in to find this derivative, f prime, which is 3x squared, times g, which is sine of x, plus f, which is x cubed, times g prime, which is cosine x. And then that's the answer. Another example, x e to the x. Again, I like to label. So f prime, derivative of x is 1. Derivative of g of x, the derivative of e to the x is just e to the x. So f prime 1 times g e to the x plus f, which is x, g prime, which is e to the x. So just e to the x times 1 plus x. Product rule, simple and easy. Alright, quotient rule. Kind of the same product rule, but just a little bit different. Alright, quotient rule says let f of x and g of x both be differentiable functions and g of x not equal to 0. So we have f of x divided by g of x. Dividing, that's why quotient. So to find the derivative of it is just f prime of x times g of x minus f of x times g prime of x. Everything divided by g of x squared. Alright, so one example, let's do 3x squared plus 5x plus 1 divided by x cubed. Alright, so again, I like to label. This is f, this is g. So f prime is 6x plus 5. G prime is 3x squared. Now we just plug in f prime 6x plus 5 times g, which is x cubed, minus f of x 3x squared plus 5x plus 1 times g prime 3x squared. Everything divided by g of x squared. So x cubed squared. So that's pretty much it. Most teachers expect you to follow it out, so let's simplify it. So we get 6x to the fourth plus 5x cubed minus 9x to the fourth plus 15x cubed plus 3x squared divided by x to the 6. Get to the 6 because the power rule, 3 times 2 is 6. Alright, so now we got to distribute the minus sign to all of these. So this becomes 6x to the fourth plus 5x cubed minus 9x to the fourth minus 15x cubed minus 3x squared. Everything divided by x to the 6. You have to distribute the negative sign. Don't forget the negative sign. It's very, very important. That's what all students usually mess up. So combine like terms. 6 minus 9 is 3. So negative 3x to the fourth. Cancel those out. The cubes. Plus 5 minus 15. Negative 10. X cubed. And we're left with 3x squared. X squared divided by x to the 6. Alright, so simplify that. You can factor out x squared. I'll just do it over here because it's right out of room. So negative 3 x to the fourth minus 10 x cubed minus 3 x squared divided by x to the 6. Factor out x squared. You have x squared times negative 3 x squared minus 10x minus 3. Everything divided by x to the 6. This cancels. This becomes a 4. So you're left with negative 3x squared minus 10x minus 3. Everything divided by x to the 4th. Simple as that. Quotient rule is a lot of work, but it is very useful. So I hope you found this useful. Alright, another example of using quotient rule is when we got to find the derivative of secant of x. And one of my students earlier today came in with a question. This is one of his homework problems. He didn't know how to solve it. So secant of x, it's the same thing as saying what? 1 over cosine of x. Well, that looks like quotient. So this is our f, this is our g. Now our f prime. Derivative of 1 is 0. Derivative of cosine x is negative sine of x. So now we just plug and chug into our formula, which is f prime times g. So it's just 0 times cosine minus f, which is 1, times g prime, negative sine of x, divided by cosine squared. Cosine squared of x. So we reduce this, becomes sine of x over cosine squared of x. So now let's rewrite this. It becomes sine of x divided by cosine of x times cosine of x. Now we can break it up. This is 1, which you should know. Sine x divided by cosine of x is tangent of x. And then 1 over cosine of x is just secant of x. So the derivative of secant x is equal to tan x secant x. And it's all thanks to the quotient rule.